Okay, this problem is a partial fraction in Calculus 2, and we've already covered the part about setting up the partial fraction, so we'll go ahead and set this one up. And we have a quadratic as well as a linear term squared, so we need to build that linear term up and multiply by x squared plus 4. So we'll set this up as x squared plus 4 plus x plus 1 to the first power plus x plus 1 to the second power. Now I apologize for the small print, but this one is probably going to be a long and tedious problem, so I'm writing smaller than normal. This is a quadratic, so it's going to get ax plus b. This one is linear, so it's going to get c, and this one is linear, so it's going to get d. And you go by the degree of the variable. So we've got it set up now. Let's multiply through by the common denominator. And when we multiply through by the common denominator, we multiply through by x squared plus 4 times x plus 1 quantity squared. That's going to leave us with 3 on the left side. Now remember, we still are integrating, but we're not putting the integral sign in front of everything because it's just extra work. So just remember that we are still in the integration part. X squared plus 4 will cancel with this x squared plus 4, and that will leave ax plus b times what's left, x plus 1 quantity squared, plus c. The x plus 1 will cancel with one of these, and that will leave x squared plus 4 times x plus 1 to the first power plus d times, and the x plus 1 squares will cancel, and that will leave x squared plus 4. So just to go over that again, we multiplied through by the common denominator. The common denominator is right here. And when we did that, the x squared plus 4's canceled, and leaves x squared, x plus 1 quantity squared. One of the x plus 1 squareds cancel here, and that leaves you with x squared plus 4 times one of the x plus 1's. And then the x plus 1 quantity squared canceled, and that leaves you with x squared plus 4. So I'm going to bring this up here and write it under here. 3 is equal to ax plus b times x plus 1 quantity squared plus c times x squared plus 4 times x plus 1 plus d times x squared plus 4. Now we've got a equation. Now at this point we can go through and try to, but we can do something. We can try to expand all of this and combine like terms and try to find the equivalent coefficients, but we can go ahead and use a shortcut and get rid of at least 2 terms by plugging in x is equal to -1. And if we do that, x is equal to -1, then these first 2 terms will go out. And that will leave you, and I'll write it down if you need to, 3 is equal to a times -1 plus b times -1 plus 1 quantity squared, and there's your 0 right there, and it'll cancel everything out, plus c times x, well that's be -1 squared plus 4 times -1 plus 1, and there's your 0 there, plus d times -1 quantity squared plus 4. And that term will go to 0. That term will go to 0 because of this, negative 1 plus 1. So you get 3 is equal to D times 5, and D is equal to 3/5. Now you need to remember that because we're going to take that and use it later. So we can find D is equal to 3/5. And I'm just going to pull that up here, and I'm going to write D is equal to 3/5. And we'll put that out to the side and save that for later. Okay? Now, we found one letter, or one variable, so now let's combine everything and see what we can do. 3, and the rest of this x is equal to negative 1. So we get 3 is equal to ax plus b times x squared plus 2x plus 1 plus c times x squared plus 4 times x plus 1, I'll do that one in just a second, plus dx squared plus 4d. And I'll focus on these two next. If we go ahead and use the distributive law here, this is going to be 3 is equal to ax times x squared is ax to the third. Ax times 2x is 2ax squared. Ax times 1 is ax. B times x squared is bx squared plus 2bx plus b. So that's that term. Now over here we got the FOIL method, and I'll put a C right here, and then I'll put parentheses. And that's going to be x to the third plus x squared plus 4x plus 4. And then, of course, this comes over plus dx squared plus 4d. Now, we need to distribute this c, and we'll get 3 is equal to ax cubed plus 2ax squared plus ax plus bx squared plus 2bx plus b plus cx cubed plus x squared, cx squared, sorry, messed up right there, cx squared plus 4cx plus 4c plus dx squared plus 4d. Now we got everything distributed and everything. Now we just have to go through and pick out our terms. I already see a couple of x cubes, so I'll go through and draw a triangle there. And we got a triangle here. So that's going to be ax cubed plus cx cubed. So those are out. All right, let's go with some squares. I see a 2ax squared and an x squared here and an x squared here and an x squared here. So I'm just going to put this in brackets right now, and I'm going to put in brackets here 2ax squared. We'll put circles around these, plus bx squared plus cx squared plus dx squared. And that's all of our x squared terms. Now let's find our x's. Plus brackets ax plus 2bx. Oops, we forgot to we'll put rectangles around these guys. 2bx. Where's another x? There's another x. 4cx. That's it. Plus 4cx. And that takes care of these guys. And I think that just leaves the constants at the end, b plus 4c plus 4d. So we'll put them at the end down here. b plus 4c plus 4d. Almost running out of room there. So now we factor out 3 is equal to x cubed, and that's a plus x, a plus c. Just kind of cleaning it up a little bit because, again, we're trying to find the coefficients, the equivalent coefficients. So we have to make these equal to the coefficients. That's a plus c times x cubed. So a plus c is the coefficient. Here we're going to take out x squared, and that's going to leave us with 2a plus b plus c plus d. And that's a d, not a 0. Plus x, and that's going to give us a plus 2b plus 4c, and then the constants just, there's nothing in common here, so it's just b plus 4c plus 4d. That's not a 40, that's a d. There. Now, the good thing about this is that we don't have a lot of terms over here, so a lot of these are going to zero out. So what I'm going to do is I'm going to rewrite everything. And I'm going to do this, kind of make it easier for you. 0x cubed plus 0x squared plus 0x plus 3 is equal to a plus c times x cubed plus 2a plus b plus c plus d times x squared plus a plus 2b plus 4c times x plus b plus 4c plus 4d, and that is the constant. Now the reason I did that was because now you have equivalent coefficients. Alright, I'm going to take a different color marker. Here is my x cubed coefficient, 0. You can see that. I don't know if you can see it, but right there is 0. 0 x cubed, a plus b x cubed. So now we can say 0 is equal to a plus c. I'm going to take another color, this purple color, and I'm going to circle or put a square or rectangle around that 0, and that's the x squared. Here's our x squared right here. So 2a plus b plus c plus d is equal to 0. And I'm going to take another color, this blue. Here's a 0, and here's its equivalent. So a plus 2b plus 4c is equal to 0. And then the constant I'll do in orange. Here's our constant, and that constant, positive 3, is equal to b plus 4c plus 4d, and that's equal to 3. Now, I'm going to stop the video, and we will continue this problem on the next video.